Welcome to the 11th and last episode of a series where I'm upgrading my mini-lathe. In this episode, we'll finally take a look at the upgraded mini-lathe in operation and take a deep dive to get familiar with the new software interface. But before we do that, let's take a quick look at how we did with the budget. So the motor was $56 US, the EC 32, power supply about $65, display $5, microcontroller board $2, $20 for a roll of PLA filament, and maybe around about $30 for other bits and pieces. Now naturally your mileage may vary, but I expect I was pretty much able to meet the original goal of $200 I'd set for myself. Alright, enough waffle, let's go and take a look at this thing. Well, here it is, in all its glory. As you can see, I've managed to maintain the lathe's luggability. The power supply sticks out a bit, but you end up having a nice little space here for your chuck key. When I'm not using a lathe, I usually remove the controller and place it on the bottom tray to avoid possible damage. Overall, I'm really happy with how it's worked out, and I think it's practical and pretty good looking too. When you first power up the lathe, you're greeted with this main menu screen. On the left side of the screen we have a plus and minus button used for adjusting stuff, and at the bottom we have 4 buttons whose current function is displayed on the screen itself. We also have this knob here that can quickly adjust values for some operations. Navigating the menu is pretty easy, and at the bottom here is the settings submenu, where the controller can be configured. There are 4 operational items in the main menu, but really it's just 2 types of displays, with the automatic adjustment being either enabled or disabled. The basic RPM mode is the simplest display. It allows you to select the RPM much the same way as the original mini-lathe controller, and the motor will operate at a given power level. Naturally the RPM will change as the load changes. Here you can see the auto symbol is being shown. Here is the gear indicator. Current RPM is shown here. This is the selected RPM. And this RPM value is linked to the knob, which changes like this. You can change the selected RPM by pressing the plus and minus buttons, or you can use the knob to select an RPM and then send that value to the selected RPM. You can also link the knob's RPM value to the selected RPM by pressing the link button. You can easily break the link by pressing the link button again, and the link is also broken when you press the send button, plus or minus button, or if a gear change is detected. Over to the right here in green, we have some general status information for the lathe, including power information, motor and power supply temperature, and the power supply's current fan speed. These will also flash and change colour should pre-configured limits be breached. And finally we have this little long black indicator. Extending from the left side of this will be a red or green bar indicating how much auto compensation is being applied. Green is shown when the power is added, red is shown when the power is reduced. Extending from the right side will be a brown bar that is shown when the current RPM is lower than that of the selected RPM. If you're not using auto compensation, then naturally only the brown bar will be shown. In the triple type displays, you can specify either the RPM, surface speed, or diameter of the workpiece. The adjustment method is much the same as the basic RPM display you saw earlier, but as there are 3 adjustable items, you need to press the select button to choose the item you want to adjust, and here you can see the item that is selected has been highlighted. The plus and minus buttons changes the selected value. Pressing the send button will update using the knob's value, and long pressing the send button allows access to the link mode. You can see that by adjusting the RPM, the surface speed is automatically adjusted. And if we change the surface speed, the RPM is adjusted. And finally, if we change the diameter of the work, the RPM is adjusted. When designing the software, I was also concerned about safety. Specifically, accidentally hitting the start button causing the lathe to unexpectedly start with the result of somebody getting hurt. So after you enter any of the operational displays, the first time you press the start button, you are greeted with this warning, which you must accept. After this, there is a 5-second abortable countdown before the lathe actually starts to turn. After starting, the lathe always takes a little time to detect the current gear before moving to the selected speed. Pressing the pause button instead of the stop button allows you to avoid the warning screen and countdown when you're in the middle of a job. So enough of all that, let's take a look at the lathe actually cutting some metal. So I do hope you enjoyed that bit of machining action, but this episode's got a little bit more to go yet. And of course, if you like this type of content, please consider to like, comment, or subscribe. Next up, we're going to take a look at the software settings. If you're not interested in that sort of thing, then feel free to skip ahead. This is the Display Preferences settings screen. In here you can decide if you want to use dinosaur or modern measurement units. You also need to specify the operational RPM range for the low and high gears. Selecting the Restore Defaults item and then pressing the plus and minus buttons together restores the default values for all items in the current screen. If you press the exit button to close the window, then any changes made will be lost. Settings are only updated when the save button is pressed, as you can see here. See, the temperature values are now shown in Fahrenheit. Now let me put that back to Celsius. The PWM motor control settings are pretty important. First you need to set the PWM settings that are appropriate for your ESC, and then you need to run a calibration operation for both the low and high gears. Select the appropriate calibration item, and then press either the plus or minus button to begin the calibration process. Reliably detecting the fastest and slowest speeds was pretty tricky actually, and you can see it dance around here while it performs this process. After this stage completes, the lathe will generate a PWM to RPM map for a given number of samples. You can actually limit the number of samples by setting the max samples value. The system can support up to 100 samples per gear, but I found with my low precision ESC, 30 steps is more than enough, so that's what I use. It takes a while for the calibration to complete, so let me abort this now so we can quickly look at the remaining settings. Okay, so let's take a look at the gearing settings. The controller needs to know the gear ratio for each gear set so it can automatically detect the current gear. I could have hard-coded those values, but I decided to make this configurable just in case. To configure, all you need to do is input the number of teeth for each gear. The ratios are then automatically calculated. You can see those here in blue. For the temperature sensor settings, all you need to do is select which sensor is used for the motor compartment and which is used for the power supply. When making the selection, the current temperature for the selected sensor is also shown. This is to make it easier to identify which sensor is which. All you need to do is add a little bit of heat to one of the sensors and you'll quickly know if you've got the right sensor selected or not. The power supply fan control settings allow you to enable or disable the automatic fan control for the power supply. Here you can see, when disabled, the fan just ramps up to 100%. Let me turn that back to auto. You can also set the speed range and temperature range, and these values are used to decide the current fan speed. The power settings allow you to make fine adjustments to get accurate voltage and current readings. The voltage is pretty easy. Just use a multimeter to measure the current 24 volt rail and adjust the maximum voltage until it shows the same value. The setting for the current is pretty much the same. Set the correct size for your shunt and amplifier IC, and then adjust the tuning and offset values to get the result you want. Actually, I found that running a current through the shunt to make this setting is not so practical. So in my case, I'm using a domestic watt meter, running the lathe, and making adjustments until the wattage value is somewhat similar. Technically, this is not a precise or accurate method, but it serves my purpose of getting some indication as to how hard the motor is working, and that's all I really wanted to know. Now I always have to point out that I forgot to adjust the current settings before I shot all the machining work you saw earlier, so the current and power values you saw in the demonstration are actually a little bit low. The alert and shutdown settings are an interesting feature of this software. It allows you to make settings which provide a warning if something's not right, and in the worst case will shut down the lathe or not let the lathe operate until the situation is restored to normal. This applies to the motor compartment temperature, power supply low voltage, and lathe overpower check. You can also select how many seconds it takes for the lathe to detect a stall before an automatic stop is executed. And this final settings window allows you to clear all of your settings back to the factory default values. Once you open this screen, You need to press the plus and minus buttons together, and then turn the lathe off and on to complete the process. After this, all of the settings will be restored to their default values. I'm not sure how useful this feature is, but I guess if there is some major settings corruption or something else that I can't think of, then this would be the ultimate way to resolve the problem. So that's about everything I wanted to cover in this final episode of the series. You probably saw and heard in the demonstration that the tool rigidity and noisy plastic gears in the headstock are still problems that probably should be addressed. But these issues are well known in the community, and this upgrade was not really about addressing those issues. As for the outcome of the upgrade, I'm very satisfied. Specifically, I found the auto compensation to work as good as I could have hoped. No nussy hunting or weird behaviour, it simply just works. In fact, I've never even noticed it when I'm using it, but it is always the option I would choose when I go to use this lathe. To sum it all up, I believe I achieved all my original goals. Well, maybe. I guess the final judgment will be if anyone is actually watching these videos. So that's it for this video series. Thank you so much for watching, and I do hope it was either somewhat entertaining or educational. I hope to catch you next time, so we'll see you then.